students, welcome back. This is Torres, elbow bump. How are you? Are you doing okay? Is your family okay? Okay, remember, if you need anything, please send me an email and I will help to get help to you. Lucky you, you get to hear my voice for another lecture, but the best part is we're going to be learning how mean, median, and mode describe how the data is alike. Yay! Before we move forward to the new material, I just want to go over frequency and relative frequency very quickly. This is an example dealing with the material that we covered in the last lecture. So here I have a bunch of numbers, right? There's 45 pieces of data right here, individual pieces of data, and it says that the following data represents the time between eruptions in seconds for a random sample of 45 eruptions at the Old Faithful geyser in Wyoming. Okay, so it's a geyser. This water just like spouts out of the earth, and they decided to time how many seconds between eruptions. One of the reasons why they call Old Faithful, they gave it that name, is because it's pretty consistent on how often it will actually erupt. So they say construct a frequency and relative frequency distribution of the data. So here's all 45 pieces of information. So here's all the 45 pieces of data. In order to start to organize this, I went ahead and put all this information into Excel, and I went ahead and ordered it from least to greatest. And when I did so, I found that the smallest value was 672. Let me make this a little bit smaller so you can see everything. Let's see, come here. Make this just a little bit smaller like this. Yeah. That might work. Okay, so when I looked at it, 672 was my smallest value. And when I went all the way up to the greatest number, I saw that 738 was my greatest value. And I want to point out one thing also, is that the first row right here is the row that I used to put the header of my column. So like the title of my column is eruptions. And then I went ahead and typed in the 45 values. That's why it ends with row 46, because we've got the header and 45 values, so 46 rows total. So I just want to point that out. So if we wanted to create bins, another way that you can call a bin is a class. If we wanted to start to create bins, we need something that is going to be large enough to have the lowest value and large enough to also accommodate the greatest value. So I'm going to go ahead and start my bin at number 670. By the way, for our class, I will always tell you where to start the bin. So, for the first time we do this, let's start with a bin of 670, and let's do a bin width of 5, and let's look to see how that's going to fall out in the following classes. Now remember, when we're making this, we can use our hands just to make sure that we are actually writing down the numbers, the beginning and the end of the bin widths. So here I have my lowest one is starting at 670, and I need a bin width of 5. So if I start here, right, I'm going to use 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Then I'm going to start with 670 and count up 5. So it's 670, 671, 672, 673, 674. So my first bin is 670 to 674. So my next bin is going to start at one number more, 675, and go up by 5. So 675, 676, 677, 678, 679. And it's going to end up here. Okay? Then I'm going to go here to the next number, which is 680. And I'm going to start here. 680, 681, 682, 683, 684. So I end up here with 684. And I keep going up by 5s until I get to a bin that is large enough to accommodate the greatest value, which is 738. Okay, so here I've got a bin width of 5, 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 and over and over and over again, I have created 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bins in order to accommodate all the numbers in this. So for this, I wanted to also, and I'm going to just try to pull this thing down so we can see this. So we've got my first bin here, which is 670 to 674, okay? And if I look at the data, I really just have one number right here that will fit in, and let's go ahead and, how can I, let's just fill this in. So 672 will fit here. I've got one number that is between 670 and 674, so the frequency is 1. And the relative frequency, I can use my calculator for that. If I can just calculator, okay. So I have 45 values. So 1 divided by 45 is 0.222. Okay, so that's my relative frequency. Relative to the whole, this takes up 1/45 of it, which is the equivalent as 0.0222 as a decimal. Okay, let's look at the next eruption, and I'm going to go ahead and just drag this down a little bit. So the next bin width is going to be between 675 and 679. Okay, and if I look here, I only have one value here that is going to accommodate that. I'm going to go ahead and put it in another color. Okay, so I also have a frequency of 1, and it's the same relative frequency, 1 out of 45, which if we use our calculator, we're going to see that 1 divided by 45 is still 0.02222. Okay, all right, let's look at the next one. The next one has, I want to know how many numbers are between bin 680 and 684. So let's go back and look at my thing. 680 and 684, I have nothing. So I have a frequency of 0, and so 0 divided by 45 is 0. Let's look at the next bin. The next bin is 685 to 689. 685 to 689, there's nothing there. So again, the frequency is 0, and the relative frequency is 0. The next bin we're going to look at is the bin 690 to 694. So again, we look at this, there's nothing there. Still nothing there. So this is not unusual. What this is saying basically is that there's just absolutely no values within there. We've got very few values that are low. We really have nothing through here, and we just keep on going. The next bin, which is going to be 695 to 699. Okay, pull up my thing. Now I'm starting to get some numbers. I'm able to get this number, this number, this number, this number, this number, this number, and this number. So all these numbers, and I'll go ahead and put them in a pretty, let's put them in a pretty green color. Okay, all these numbers, and there's 7 of them. See, if you look down here, the count is 7, or if I wanted to count them, 1, 2, 3, 4, 5, 6, 7. Okay, I have 7 values. That means that 7 out of 45 are going to have my, so 7 out of 45 is my relative frequency. So 7 divided by 45 equals, I get 0.1555. So if we were going to round, it'd be 0.1556, right? The next bin is going to be 700 to 704. See, look. And then if I go over here, I know that's going to fit, that's going to fit, that's going to fit. And this time, let's go ahead. Oh, sirens are creepy, aren't they? Okay. This time we're going to have also another 7 number. Look down here, it'll say count of 7. And I can also count them 1, 2, 3, 4, 5, 6, 7. Okay, it's going to have the same relative frequency because 7 out of 45 is still going to be 0.1556. The next bin is going to be 705 to 709. So let's see if we have anything. Well, it looks like we have two numbers that are between 705 and 709, and I'll go ahead and make these this gray color. Okay, and so I have 2. So 2 out of 45, 2 divided by 45 equals 0.044444. So I have 0.0444 here. 710 out of 714 is my next bin. Going over here, 710 to 714, I have all these right here. So I'm going to go ahead and put these in a color. Can you guess what color I'm going to use? I'm going to use bright yellow this time. Oops, bright yellow. Okay, so that is 5 values. So if you see 1, 2, 3, 4, 5. So I have 5. If I use this, I've got, so if I put 5 divided by 45, I get 0.111111, and that would be my relative frequency. My next bin is going to be 715 to 719. So let's look at my numbers here again. 715 to 719 is going to take up these 4 numbers. And this time I'm going to do, what number should I'm going to do purple. You can't see purple very well. I'm going to put bright red. Okay, so bright red has 4 right here. So I have 4 out of 45. So if I go back here to my calculator, clear, 4 divided by 45 is 0.08 and 89. So if I round it off, I get 0.889. Okay, let's see how many more we got left to do. 720 to 724. Here I got 720 to 724. All these numbers are going to fit in there. This time I'm going to use this kind of pale blue. So it's 6 numbers, 1, 2, 3, 4, 5, 6. Here I have 6 out of 45. Bring my calculator over, clear. 6 divided by 45 equals, and I get 0.133333, which is the number that I have right here. Okay, let's scooch this down. 725 to 729, and I've got my number right here, 725 to 729. We'll take up these numbers. So now I have, let's do, I don't even know. Let's do this weird goldenrod yellow. I don't even know if I've used these colors already, but it's okay. They're not next to each other. So here I have 1, 2, 3, 4, 5 numbers. Again, I have 5 numbers. I already calculated 5 once before, so I know the relative frequency is 0. I don't know why that 4 is there. 5 divided by 45. Yeah, not sure where that 4 came from. It should be a 1. So 730 to 734. If I bring up my thing, 730 to 734, I've only got 3 of them. I'm going to put in a light gray. So 3 out of 45. Let's bring this over. Clear. 3 divided by 45 equals 0.6667. Okay, and now we're to the last one. The last one is 735 to 739. Bring this over. That is 4. I'm going to go ahead and put this one in this yucky green color. Okay, so 4 divided by 45 is the same number as it was here. Okay, and if we were to go ahead and make a histogram with that, we would get something that looked something like this, where you have the 2 1s, right? Then you have the space for all those zeros, and then you start to get the different distribution of the histograms, where we had some of them that were, we had several, like right in through here, where we had this group right here, which is this one right here, and then we had 7, which makes sense because look, it goes to 7. This next yellowish color was also 7, and that goes up to 7. This next one was only 2, so this gray only went to 2, and so on and so forth. So this is what it would look like if the if you used a bin width of 5. So we're going to do the same thing again, but this time we're going to have a bin width of 10. So we can kind of compare what happens when you have different bin widths. Now we're going to go ahead and start with 670 like we did the last time, but this time we want an interval that will be able to enclose 10 numbers. So let's start with the first number. Here we have 670, 671, 672, 673, 674, 675, 676, 677, 678, 679. Okay, so here we have all of these are 10 numbers. It's going to seem weird because it's going to go up to 679. Okay, but it is 10. I'll do it one more time. 670, 671, 672, 673, 674, 675, 676, 677, 678, 679. 10 numbers. We're going to go ahead and do it again with the 680, right? Starting at 680. So the next number after 679 is 680. We're going to go 680, 681, 82, 83, 84, 85, 86, 87, 88, 689. Same next number would be 690. So we'd start here with 690, 690, 91, 92, 93, 94, 95, 96, 97, 98, 699. And we would continue the pattern until we got to an interval that would enclose that greatest number, right? The greatest data value, which is 738. So this time I'm going to have 1, 2, 3, 4, 5, 6, 7 bins instead of the 14 I had the last time. And go ahead and exit out of this, okay? And I'll be able to pull this down here. And I'm going to go ahead and bring over my data again, okay? And let's look at my different bins. So my first bin is going to be 670 to 679. And if I look over here, between 670 and 679, I have 2 numbers. And I can't remember what colors I made the other ones in. I really can't. So, you know, pardon me if they don't match exactly, but we'll just do this color. So we've got 2. If I bring over my calculator over here, I've got 2 divided by 45 because there's still 45 values. We have the exact same numbers as we did before, and our relative frequency is 0.44444. Okay, and if I drag this down just a little bit more, you'll see it. There it is. My next bin, bring that down, is 680 to 689. So if I pop up here, 680 to 689, I don't see anything. The next number that I have that I could possibly use is 695. So again here I have a frequency of 0 and a relative frequency of 0. I'm going to go ahead and drag this down one more time. Here it pops up. I have an interval between 690 and 699. So the numbers that fit between that are this one, 695, 695, 696, 698, 699, 699, and that is a count of 7. I'll go ahead and make it a bright yellow number. Okay, and I have 7 divided by 45. So I'm going to bring my calculator over, clear it out. 7 divided by 45 equals 0.155555. So if I round it out, it will be 0.1556. Let's go down to the next bin. The next bin that I have is 700 to 709. So let me go ahead and pop this up. 700 to 709, I've got these 700, 702, 703, 6, 7, okay, I've got these. All right, so now let's go ahead and let's make this one bright green. Bright green, awesome. Okay, this time there's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Okay, I'm going to go ahead and bring my calculator over. Make sure you always clear it. 9 divided by 45 is going to be 0.2. Okay. Keeping it moving. The next number that we're going to look at is between 710 and 719. So I'm going to bring this up. 610 to 719, so 711, 713, 14, 16, 18, 19. Okay, all of these will fit, and let's make this a gray. Okay, so again, I have 9 out of 45. My relative frequency is still 0.2. Drag it down to the next bin. The next bin is 720 to 729. Here I've got 720, 721, 22, 23, 44, 26, 27, 28, 29. Okay, I'm going to go ahead and make that one the bright yellow. And if I count those up, you can see here that it's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it's 11 out of 45. I don't have that calculated yet, so I'm going to go ahead and drag my calculator over. Clear, clear, clear. 11 divided by 45 is going to be 0.244444. The very last bin is going to be 730 to 739. And so if I bring this up, I've got that 730, 31, 33, 35, 36, 38. All of these will fit into, let's see, what color can I use? Did I already use bright blue? I'll use bright red. Okay. All of these numbers will fit. There are 7 numbers here. So 1, 2, 3, 4, 5, 6, 7. 7 out of 45. Clear, clear, clear. 7 divided by 45 equals. And I get 0.155. If I round this next number, it's 6. And here it is again. Okay. So let's look at what this would look like if it were a histogram. Here you can see that I have the very first interval. We had 2 numbers, right? So let me bring this guy over one more time. Here we had 2 numbers, and this column only goes to 2. The next, we didn't have any numbers between 680 to 689.99999. We had nothing there. So the next column we see is this one of 7 values, which goes to here, 7. The next column that we see is this green one, right, where there are 9 values. And you can see that this one goes all the way up to 9 values. So does the next one, where we had 9 other values. So here we have these that are equivalent. They're the same height. The yellow was our mode, right? It kind of created our mode, our tallest column right here. And so this one had 11. So we have this very tall column. And then the last one had 7, which was the same as this one. Okay, you can see how the distribution worked. Let's compare the 2 columns. Okay, remember the first one we did, we had a bin width of 5, and the next one we did was a bin width of 10. Well, first thing that you can look at when you look at the histograms for each one, well, the bin width of 5 is much more narrow than the bin width of 10. Also, here we have many more bins than here, right? Here we only had 7 bins, here we had 14 bins. And you can also take a look when I look at this, when I show you what this looks like in terms of comparing the 2 bins. Here was my first number with 5, right? I have so many more colors here in this column than I do here when my bin width was 10. I don't have as many. And if I make this maybe a little bit smaller, that will become much more apparent. Where here I have many more colors, here I just have these. Okay, so really the size of the bin will affect what the histogram looks like. So if I were going to basically give you a big idea for this, the big idea is that changing the width of the histogram matters. Your choice of bin width determines the number of the intervals of the columns. And this decision with the choice of a starting point for the first interval affects the shape of the histogram. Okay? If I go back to my previous slide, here I have the highest point of my histogram, the mode, and I'm going to go ahead and get my pointer. Notice that the highest point of my histogram is right here, kind of a little bit off center of the data, where here my highest point of the data is towards the end, towards the higher end of the data. So here I'm getting two different shapes. However, the data is the same. The only thing that's changed is the bin width. So the last part of the lecture I want to talk about is how the mean, median, and mode all describe how data is alike. It's not unusual for a student to start learning about mean, median, and mode very early in their academic career. You probably started having experiments and things like that, or working with mean, median, mode as early as 4th, 5th, 6th grade. So these calculations may seem very clear to you, very obvious. But more than anything else, I really think that it's important to just do a real quick review of what each one means. So let's start with the mean. The mean is also called the average of a group of numbers. In statistics, we just call it the mean. And the mean is an even distribution of the quantity amongst the number of cases. It's the number that most describes the set of data. So what do I mean by an even distribution? So let's look at these 5 columns, okay? So here's the purple column, here is the pink column, here's the green column, the red column, and the turquoise column. And I have 5 columns, and I have 15 colored boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, if I wanted to make all of these columns the same height, I could take a couple of these greens and move them over, and maybe one of these blues and move them over, and I would get something that looks like this, where what I did is I just took pieces from taller columns and put them with the smaller columns so that they all evened out. So here we can distribute them equally, and all of the columns have the same number of colored boxes. This is what the mean is doing. It's an even distribution. So this even distribution is really what it's doing is it's just taking up all these numbers and it's adding it up. So I took the 1 purple, the 3 pink, the 6 green, the 1 red, and the 4 turquoise, and I got 15, and then I divided it equally amongst the number of the 5 cases. So 15 divided by 5 is 3, and as you can see, each column has 3 colored boxes now. So here's another example with just test scores for a math class. Here I have 1, 2, 3, 4, 5 test scores, and let's go ahead and add up all the numbers. So I've got 82 plus 93 plus 86 plus 97 plus 82, and I get the sum, which is 440. And since I have 5 cases, then I'm going to go ahead and divide by 5, and I get the mean is 88. The notation for mean is different if you're talking about the population than when you're talking about a sample. For notation for the population, the mean is the Greek letter mu, and it kind of looks like this sort of like cursive lowercase u kind of. The notation for the sample mean is a cursive X with a bar over it. It's referred to as X bar, and it just looks like this X with this bar over it. So if you see a mu, it's because it's talking about a population mean, and if you see an X bar, it's talking about the sample mean. For the most part in my class, I just work with samples. The median is the next measure of center that we're going to talk about, and the median is the middle value of the data. It divides the data exactly in half, so that half of the data is less than the median and half of the data is more than the median. You can kind of think of it as the balancing point of the data. So let's just look at these 5 test scores, okay? Here we have our 5 test scores, 1, 2, 3, 4, 5. They're sort of in all different order, so we want to make sure we put them in order. So here I have 78, 79, 86, 93, 97, so they're all in order. And just by looking at this, you can tell that the middle number is this 86. So half of the data is less than 86, and the other half of the data is more than 86. 86 is the balancing point. So if you have an even number of test scores, you're going to do things just slightly differently, but the idea is still the same. There's a number that will balance half the data on each side. So if you have these, so here I have 92, 86, 94, 83, 72, and 88. I'm going to go ahead and put them in order. And if I notice this time that there are 2 numbers that are exactly in the center, right? Well, between 86 and 88, there is one number. That one number is 87. So here's my 2 middle numbers, 86 and 88. So the number that's exactly in between is 87. Another way that you can find the median when you have an even number of test scores by adding up the 2 numbers and dividing it by 2, and you'll get 87. For median, you have the same notation regardless if you're working with the population or the sample. The notation for the median is a capital M. The mode is the number that appears most frequently within the data set. It's really easy to remember because mode is most frequent, so you kind of have that same sound. If you're looking at data visually, so you're looking at a bar graph or histogram, you'll be able to tell where the mode resides because it's the tallest column. So here's a list of temperatures that we have in 1 week. We can put them in order if you want to kind of have a very clear representation of where the mode is, but it's not really necessary. And you can see that of the days of the week, 77 was the temperature that occurred most frequently. Therefore, the mode is 77 degrees. There is no notation for the mode. So what's the big idea? Today's big idea is that measures of center describe how the data is alike. The mean is the even distribution of all the values amongst each case. The median is the balancing point of the data, and the mode is the most frequent value, which you can see as the tallest bar in the histogram. The other big idea that we talked about is changing the bin width of a histogram matters. Your choice of bin width will determine the number of intervals or columns that you will have. This decision, along with the choice of starting point for the first interval, affects the shape of the histogram. So that's it for today. With that said, don't forget to check your emails, check Blackboard, do your homework, and subscribe to this channel. Even better, hit that notification bell so you know when there's a new video for this course. Okay? This is your teacher, Tora, saying stay safe, and I will be waiting to give you your virtual elbow bump in the next video. Ciao!